Non-recursive descent parser. And suppose we have this grammar e tends to e dash tends to epsilon plus t dash, t tends to ft dash, t dash tends to epsilon star ft dash, and f tends to id oblique e. Suppose we have this grammar and we want this string. So how it will execute in with the help of non-recursive descent parser, let's understand. Initially we understand in the normal way how it will run execute. So e tends to te dash. First we take e tends to te dash. After that, what is required id. So further we are going to break this t into tends to ft dash from this production. So we are going to write t tends to ft dash. Then what is required? id is required and f tends to id. So we will write here id. Now what is required? Plus sign is required. So in what we have plus sign, we have e dash tends to plus te dash. So this will we consider as epsilon. We will put epsilon because t dash also tends to epsilon, and here we take another production of e dash, that is plus te dash. So we will write like this, plus te dash. So from here we will get id plus. Now what is the requirement? Next id. So t tends to, again we will take the same ft dash. So we will write here ft dash, and from this f we will get the id. So we will get id plus id. From here now t dash, what is the requirement? Now we require multiplication. So we have production t dash tends to star ft dash. So we will take this production here, star ft dash, and from this f we will get another id. What is required? id plus id star id. So this f will go to the id, rest is not required. So we will assume at t dash tends to epsilon, we put here epsilon, and this e dash also we put epsilon. So in that way we will get id plus id star id. This string we will get. But how it will function in respect of stack, we can simply see how it will work in non-recursive descent parser. So initially start with the stack. How it will work, let's see. So first what we have, start with the e. So e tends to te dash. So we will write and we assume initially that we have dollar symbol because it shows this is the end of the string. So we will write e, start from e tends to te dash. So we will write like this, te dash. Now from here we can simply cross check te dash. So first we are going to further take production for t. So we will cut this one and we will write the production for t. So what they are, ft dash. So we will write ft dash. Fine. And now again, what is the production for f we are going to take? From here we can cross check. So we are cutting f, and instead of f what we are going to write? We are going to write id. So from this id what we will get? This id. So we can simply say we will reach to the look ahead symbol. We will reach to the look ahead symbol. This is the first symbol which we can consider as a also. Look at symbol, we will reach this. Now again what is the requirement? This requirement is plus. So from here we can cross check what is the production for e dash we are going to take, and this e will also get cut because e tends to te dash we already taken. So this production is occur. After that we take te dash, then after that we take t tends to ft dash. So this production is cut, and when after that we took f tends to id. So this is cut. Now what is left? Left e dash, because t dash from here it is not required, so we will assume we will take production t dash tends to epsilon. So what is left here? E dash. So E dash, what is the E dash? We take another stack from here, start with the dollar symbol, and what E dash tends to, we will write here. E dash tends to what we have taken plus TE dash, so we will write plus TE dash. So we will write like this, plus TE dash. E dash tends to, from here we are writing this production. So first after ID what we will get plus, so it is over. So now what is the requirement? Next, what is the requirement? We need another ID, so we are taking this production T tends to FT dash, so this will get cut, and what we will get? FT dash. From this T, what we will get? FT dash, this production. So that's why we I cut the T, and instead of T what I'm writing FT dash. Then FT dash, because we need ID, so again F will get cut, and what we will get? ID. So what we will get till now? ID plus ID. This is ID, this is plus, this is ID. Now what is the requirement? Requirement of multiplication. So what is left? What is left? This is over. T dash is left, so T dash, we are going to take another production T dash, so we are going to make another stack here, T dash. So what is the requirement? We need to take this one production because we need multiplication, so we are writing FT dash instead of T dash. So instead of T dash, what we are going to write? This we are going to write star FT dash, star FT dash. So this will get cut here, star FT dash. So we will get multiplication, so this is over. And what is the requirement? ID is required, so instead of F what we will write? ID here, so that's why T dash is cut. Then what is left now? What is left now? Dollar, because it will show the end of the string. What is left here? E dash is left, and from here T dash is left. So we can simply see we have ID plus ID star ID. We will get our string, so this is not required. So in place of T dash we will put simply epsilon, instead of E dash we will simply put epsilon. So in this way a non-recursive descent parser will function, and with the help of a stack it will reach to the whatever string we want with the help of production of the given grammar. And the grammar should not have left recursion, as we removed in the last lecture. Remove the left recursion from the grammar, and after left recursion this is the grammar, and so through this grammar we reach to that string with the help of non-recursive descent parser with the help of stack.